Hello, welcome to part 10 of Toxin Sequestration Theory, or TST. This is my new theory of cancer. I'm very excited about it. It explains many phenomena in cancer that the mainstream theory can't explain, like why tumors form in specific organs and not others. And I also wanted to thank many of my YouTube followers for helping me to get the word out. Recently, I appeared on a couple podcasts. I was on Dave Mack's podcast, the Terrain Theory podcast, as well as Bart Kay's podcast. And this is really helping to get the word out about this theory. Thank you guys so much for helping me spread the word. And this theory is very different from the mainstream theory. Mainstream, of course, argues that tumors are selfish, malignant, uncontrollable, and we are saying the opposite. We're saying that the tumors are actually the body's defense mechanism against toxic overload. It's extra tissue that the body builds on purpose to help itself to store and process toxins. And hence the name toxin sequestration theory. This implies that the tumors are actually sequestering and pulling in toxins, trying to protect the healthy tissue from the horrible effects of these toxins. And I've argued that cancer is actually not a disease. Rather, it is a symptom of toxic overload. And the true disease is actually toxic overload. So, I've talked about a whole long list of toxins that cancer tumors try to pull in and sequester and store. I've talked about the sugars, glucose and fructose. I've talked about ammonia. I've talked about seed oils. Talked about microplastics, ethanol, drinking alcohol, as well as cigarette smoke, mycotoxins, the mold toxins, as well as some of the toxic metals, heavy metals and iron, as well as the plant toxins like oxalates. And so there's a really long list of these chemicals that cancer tumors have been shown to sequester and store and process. So the story fully checks out in every case. I've also talked about how do we explain things like metastasis? How do we explain the fact that cancer tumors appear in specific organs and not in others? And all of that is fully consistent with this theory. I've even talked about spontaneous tumor regression, which is an idea that if you do manage to get on a low toxin diet and you happen to have a tumor, there's medical literature saying that this can lead to the spontaneous regression of the tumor getting decommissioned. Basically, the body no longer needs the tumor if you're not exposing yourself to toxic overload. And so there are ways to encourage sort of the disappearance of tumors just naturally without harsh medical treatments. And so that's very encouraging. So that's about how tumors actually disappear. But I haven't covered yet how tumors actually form. Like what makes a tumor form? What is the thing that triggers tumor formation? And what is the process by which they form? And that's what I'm going to talk about in this video. The other thing I'll talk about in this video is the ancient history of tumors. Like when did tumors come to be in the animal species? And is it just humans that have tumors, or do other animals have tumors as well? And so we'll get into some of the ancient history of that. And I did want to give credit to one of my YouTube followers. So there was a question that was on one of my videos that actually posed the idea that could tumors have actually arisen in ancient primordial times as like a detox organ. And one of my YouTube followers actually pointed this out. And it was a great idea. I looked into it. It's actually right. And I'll talk about that in my video. All right. So let's start off with how tumors actually form. Now, I will mention that it's not just the chemical toxins that trigger tumor formation. There's also physical stressors, things like X-ray radiation and UV radiation. I've covered these in previous videos. But the common theme is that all these stressors, whether it's chemical toxins or things like radiation, they all create oxidative stress, which is a fancy name for basically these chemicals called reactive oxygen species, ROS. And so ROS are the underlying mechanism for oxidative stress. And these little ROS chemicals basically burn your body from the inside out. They oxidize everything. Needless to say, it's not good to have like a fire burning inside your body. So they're very bad for us. And they are, in my opinion, the primary cause of chronic disease. And our body wants to do everything that they can possible to reduce their tissue's exposure to ROS. ROS are legitimate evil villains, right? We don't want them, and the body wants to sequester anything that produces them. And so, in my theory, the reason cancer tumors form is because locally, in some tissue, the ROS levels exceeded the body's threshold. And I call that threshold the ROS budget. I basically argue that the body has a budget for how much ROS it can handle locally in each tissue. And if you exceed that budget, you can end up with a cancer tumor because the body says, if you've exceeded the budget, then I have to start to shove toxins into little vaults, storage vaults, in order to lower the ROS levels. So yeah, I thought I would talk about how these tumors are formed, and it is interesting that the body actually has a sensing mechanism for ROS levels. I found this super fascinating because in order for the body to know when it exceeds the ROS budget, it actually has to have a sensing mechanism. It actually has to know, like, oh, what are the ROS levels in each tissue? And it does. It has like some, and I don't want to bog you guys down with too many, technical details, but I will give you the names of a couple of these sensing pathways. So the biggest one is something called NRF2. NRF2 is like the master antioxidant regulator, and it is the number one pathway by which the body senses local ROS levels. That's one pathway. Another pathway is something called AMPK. It detects both the energy depletion and redox imbalance. And then there's a third pathway, which is mitochondrial retrograde signaling. And again, apologies for being a little bit technical here, but basically these are the mitochondria themselves acting as ROS sensors and then sending distress signals. Yeah, all right, so there's several different, I'm just pointing out the fact that there's several different pathways that the body uses to actually measure or sense what the local ROS levels are. And, once we accept the fact that the body, that immediately implies, by the way, that the body cares a lot about ROS levels, because why would it have sensing mechanisms for ROS levels if it didn't really care about it? So this actually casts more importance, to ROS, because it says, all right, the body does care a lot about ROS because it has sensing mechanisms for that. But that's basically step one of tumor formation. Step one is it's sensing ROS levels, and whenever you locally exceed your ROS levels, then the body says, all right, we need to start forming a tumor. And then, what's step two? Well, step two is basically the body recruits a construction crew for the tumor. It doesn't just rely on random cells. It tries to recruit, pre-adapted or highly resilient cells, things like stem cells, for example, that are naturally more resilient to oxidative stress. And these are like pre-vetted cells because they're good at surviving in a toxic environment. This can often explain why tumors appear to arise from specific cell populations rather than random cells. I've talked about this, by the way, in the context of metastasis, where the reason metastasis kind of reuses the cells from the first primary tumor is because those cells are pre-adapted for storing toxins, right? So it doesn't just say, oh, let me just build a tumor from scratch. It says, well, I already built a tumor over there in that other organ. Let me just pull some cells from that other organ to start my new storage vault in this new organ. And that sort of explains why cancer cells actually migrate in metastasis. And the same thing is, to some degree true in starting a new tumor. Whenever, the body wants cells to start a new tumor, it doesn't just pick random cells. It tries to pick cells that are well adapted and, will be able to withstand the highly toxic environment. All right. And then, step 3 would be metabolic reprogramming. As we've talked about before, you have to actually change the metabolism of these cancer cells for them to act as storage vaults. You can't just run your mitochondria at full speed in the presence of all these toxins. So you have to actually reprogram the metabolism. You have to shift from respiration to fermentation. That's called this Warburg metabolism. And then you have to downregulate the mitochondrial metabolism. So you have to kind of slow down the mitochondria, downregulate some of their processes. Otherwise, you would generate too much ROS. And then you have to start upregulating the antioxidants inside the cells, as you can imagine. All right, that's step 3. Now, step 4 is start sending infrastructure to the cancer tumor, because you don't just want the cancer tumor to kind of sit there without any blood vessels going into it, because this is a detox organ, right? You're building a detox organ, and so you have to start supplying body fluids to the detox organ in order to, detoxify all the chemicals in the blood, right? So you have to do angiogenesis. Angiogenesis is a, name for building new blood vessels. And so you have to actually build new blood vessels that go into the tumor so we can send the blood into the tumor so that it can detoxify the chemicals in the blood. And then there's other kinds of things. You have to form something called stroma. These are fibroblasts or supportive cells that create a structural scaffold for the tumor. So the body, actually makes a scaffold to, support that tumor, to hold it into place mechanically, right? You can think about this this makes no sense from the perspective of cancer is trying to destroy the body, because the body's providing all this infrastructure to mechanically and physically support the cancer tumor. That's step 4. And then finally, step 5 is just, containment and stabilization. The vault is reinforced with physical barriers like fibrosis and biochemical defenses. And then, of course, the toxins are sequestered, and the structure is maintained as long as the toxic pressure remains high. So those are basically the 5 steps of tumor formation. So step 1 is detection, that is detecting ROS overload. Step 2 is recruitment, where you recruit these pre-adapted cells. Step 3 is metabolic reprogramming. Step 4 is building infrastructure. And step 5 is containment, or reinforcing the vault. All right, so there is something that goes on basically when the body is starting to build a tumor, and that is deciding where to build it. I've talked a little bit about this before, because I've talked about how cancer tends to form in specific organs, it tends to form a lot in the prostate or the breast or the pancreas or the liver or the lungs, in the skin. And so, but then not in the heart or the spleen. So there's certain organs where it decides to build in, and others where it just decides not to build in. And so it has to go through a decision process in real time. And that's actually kind of interesting, how it goes through that decision process. And it's, like I said, it does first look at the local toxin concentration, and it'll naturally favor building a tumor in the hotspot where the ROS levels are most intense, right? So the first thing it does is it might literally just build a tumor where it senses the most toxicity, right? If it's sensing all this oxidative stress, it may just decide to build it right there where the problem is. But it'll also consider the pre-existing infrastructure. It'll consider that some tissues already have strong detox enzymes or storage capacity, like the liver. Liver is really good at handling all these different toxins. Similarly, the breast has hormone metabolizing pathways that are supportive, and so it will kind of balance local versus global things in the sense that it will consider like, oh, should I really build the tumor here where the toxic load is, or should I look for help from my detox organs because those guys are really good at storing things too. So it'll weigh that balance. And also it'll consider growth tolerance. It'll consider sites that can physically accommodate a growing mass without immediately compromising vital function. Because if you try to build in a tissue like the heart, where a growing mass would compromise the function of the organ, then obviously the body doesn't want that. And then also it'll consider isolation potential. Basically, tissues that allow the body to wall off toxins really well are preferentially chosen. So in two tissues that come to mind there are the skin and the lungs. In the skin, it's really good at kind of just like walling off toxins inside the skin, not allowing those toxins to spread more broadly. So skin is great for that. And then the lungs also has this mechanism as well. It's able to wall off toxins inside the lung tissue. So that's why skin cancer and lung cancer are very common. Anyway, so those are basically some of the principles that the body is kind of weighing when it chooses where to put the tumor. And I also want to get to this principle of this sort of idea that one of my YouTube followers brought up, which is that like this is not a new thing, and cancer tumors are not a new invention that just happened in the past 100 years. Rather, they date back millions of years, and it's not even unique to humans. Actually, other animals like reptiles, lizards, and turtles, they've seen fossil evidence of tumors in all these different species of animals. So cancer tumors are actually throughout the whole animal kingdom. Even they've found evidence for tumors in invertebrates. So animals that don't even have like a liver. And this points to the fact that tumors look like they are the original detox organ. Like they actually predate the animal liver. And basically, actually I should say the vertebrate liver. So livers is just for vertebrate animals. And vertebrates are basically like 400 million years ago and onwards, whereas these ancient tumor organs were like 600 million years ago, even before vertebrates. They have fossil evidence of this, and there is a fossil of a 240 million year old turtle that had bone cancer. Actually, it had a tumor called osteosarcoma, which is a malignant bone tumor. And you can look at my blog to see actually pictures of that turtle's bone tumor. But you can see it's like a big growth growing on the bone of the turtle. They have fossil evidence of it. And so, yeah, it's very interesting that, a 240 million year old turtle had bone cancer. And of course, this raises questions like what was going on back then, 240 million years ago. Did they have toxins as well? Now, they didn't have microplastics, right? And they, probably didn't have cigarette smoke or drinking alcohol, ethanol, but they had other toxins naturally occurring. And most notably are the plant toxins, the plant defense chemicals. Back then, there was chemical warfare happening between the plants and the animals. The animals wanted to eat the plants, right? Just think of all those plant-eating dinosaurs that were just eating plants all the time, like Triceratops, etc. And those plants don't want to be eaten. Plants are living organisms. They want to survive. And so they developed defense chemicals, plant toxins, hundreds of millions of years ago to try to, fend off these animal, reptiles and other species from eating them. And those animals in turn developed defense mechanisms against the plant toxins. And that's, was what a tumor was. So back then, when a turtle had a tumor, it's like, okay, well, I'm exposed to all these annoying plant toxins. I got to shove them into a tumor. And that helps to protect the normal tissue from the toxicity of plant toxins. And it wasn't just the plant toxins, it was also things like volcanic activity, which was very prominent, hundreds of millions of years ago, stirred up a lot of toxic metals, like heavy metals from underground, and then they had to protect themselves from heavy metals as well. So that was their toxins. Like I said, heavy metals, plant chemical warfare, and that's what our ancient animal ancestors had to deal with. Of course, we have some different toxins now, some new toxins that they didn't have to deal with, and that's why this ancient mechanism seems to be popping up more and more and more. But like I said, it's really fascinating that the tumor predates the liver, and the liver is our primary detox organ now, whereas now the cancer tumor is like our emergency secondary detox organ that we only initiate in emergency situations. But it's fascinating that this used to be the primary detox organ before the liver existed. All right, so naturally, you can think about implications of what this implies. We should think about how sophisticated our bodies are. Our bodies are these amazing machines that are very carefully thinking about what to do. Like, I've tried to present this how tumors form as a sophisticated mechanism where the body is carefully weighing, where should I put the tumor? How much oxidative stress am I under? And how do I provide infrastructure to that tumor so that it's well equipped to do its job as a detox organ? This is really sophisticated. So our job is to just first and foremost not fight what our body is trying to do. Recognize the brilliance of our body and recognize what it's trying to do and try to help it out. Of course, we want to lower the toxic load in our body, try to reduce our dietary toxins, reduce our environmental toxins, support our detox organs. And all of this goes in line with low toxin diets, things like animal-based carnivore diets, as well as things like fasting to reduce toxic exposure, and of course getting yourself out of these really intense environmental toxic areas like industrial areas as well. So with that, I think that sort of covers the video. In this video, I talked about how tumors form and what is their kind of ancient primordial history. Thanks for listening. Let me know your thoughts.